This video homework assignment is about long division with polynomials, and I want you to take a look at the first example. We're just going to jump right into it. This is just a regular long division problem. So you probably learned this in maybe 4th or 5th grade. We're going to set it up with the doghouse. I don't know if you call it that or not, but the 7 would be on the outside, and then inside the doghouse is the 3,192, right? That's what I'm going to refer to it as from now on, so you'll just have to get used to it. And first thing we have to do is look at this 7, and how many times can it go into 3? None, right? It won't work. So then we look at the first 2 terms. How can we get 7 to fit into 31? How many times can it fit into 31? And that should be 4 times, right? And when we work backwards and do 4 times 7, let me erase that. 4 times 7 is 28. So right up below it, this should be refreshing your brain a little on this type of stuff. Subtract that 28. So whatever this number is here, always subtract it. And 31 minus 28 is 3. Carry down the next number, which is a 9, and start again. So now how many times can 7 fit into 39? 5 times. And when we work backwards, 5 times 7 is 35. Remember to subtract. And 39 minus 35 is 4. Carry down that last term, or 2. How many times does 7 fit into 42? This one is 6. 6 times. And when we work backwards here, 6 times 7 is 42. So it works out perfectly, right? And when we set up our subtraction, we have 0 at the end. So that's our remainder. For all the examples today, 0 will be a remainder. If you get anything else, you need to follow me because you messed up somewhere along the line. So our final answer here, just to summarize what we did, 3,192 divided by 7 equals 456. Okay, that's long division with numbers. We've done that before. Now we're going to add in the new part. So moving on, example 2. Set up the problem as a long division problem. So your x plus 2 will be on the outside. And inside the doghouse, x squared plus 4x plus 4. Now this part out here, the x plus 2, can trip people up, but I just want you to focus on the first terms. So look at the x out front here and the x squared, the very first terms of both outside and inside the doghouse. How do we get from x to x squared? We multiplied by an x, right? So write that up here on top. Oops, not x squared, x. Then we'll erase this. Before, in our old long division problems, we just had to multiply this, whatever this was here, by the number out front, right? But now that won't work anymore because we have 2 terms out front. So you'll have to distribute this x onto both terms. And when we do that, we'll have x times x, x squared, x times a plus 2, so we'll have a 2x. But remember, with long division, we want to subtract those away. So whatever the signs are, flip them. Now when we do that, x squared minus x squared is 0. You can write it if you want. And for a positive 4x minus 2x is 2x. And just like in regular long division problems, you bring down the next term. So let's bring down that plus 4. And if we erase the stuff that we don't need, we don't really need that 0 there. We're just left with 2x plus 4. Let's start over. how do we get from x to 2x? We multiply by 2, a positive 2. So write it up there. And when we distribute back, draw the arrows. This will help you not forget. When we multiply back out, so 2, a positive 2 times an x, we'll have 2x. And a positive 2 times a positive 2 is a positive 4. But remember, subtract them, both of them. And when we do our subtraction, everything disappears, right? 2x minus 2x is 0. 4, a positive 4 minus 4 is 0. So you're just left with 0 as a remainder. And I told you that that would happen, so that's good. Yay! And so our final answer is what's left on the top, x plus 2. Alright, we just finished our first example. How do you feel? Let's do another one. Alright, what do we have to do first? Set it up like a long division problem. Put that x plus 1 out front. And inside the doghouse, we've got a lot going on. Alright. And I told you, don't worry about this stuff out here. Just look at the first terms, both inside and outside. How do we get from x to x cubed? We multiply by x squared. Now distribute it back out. And when you do that, you'll have x squared times x squared, which is x cubed. And x squared times a positive 1 is x squared. And remember to subtract both of them. When you do that, on this problem, something funny sort of happens. Both of the terms end up being zeros, right? So you're left with 0. Here's where, okay, we still carry down the next term. But we're also going to end up needing to carry down both terms. And you'll find out why in a second. If this didn't initially come to you to carry down both, that's fine. You'll understand why in a sec. Alright, so let's get a different color here. Let's go with green. How do we get from x to negative 9x? We need to multiply by negative, first of all. And we need that 9, right? Other than that, it's good. So when we distribute back out, negative 9 times x is negative 9x. And negative 9 times a plus 1 is negative 9. But remember, we want to subtract them. And since these terms were already negative, then we just switch the signs, so make them both positives. And now you see why it's good to have brought down this term, this minus 9 from the original problem, because we start by subtracting the first two. Minus 9x plus 9x is just a 0, and minus 9 plus 9 is 0. So once again, we have a remainder of 0. And our final answer for x cubed plus x squared minus 9x minus 9, all divided by x plus 1, is equal to 9, or x squared minus 9. So there's your answer. Okay, let's do one more example, example number 4. This one, if you feel like you're getting the hang of this, I want you to try it on your own first. So figure out how to set it up, and look at those first terms, and set up your long division. Get as far as you can on your own, but I'm going to work the example right now. So pause it if you want, or just keep on watching and copying. Okay, let's set up our division, long division problem. X plus 5 will be on the outside. That's what we're dividing everything by. And we're dividing it all by, or we're dividing this expression x cubed plus 11x squared plus 39x plus 45 divided by x plus 5. So look at our first terms. To get from an x to an x cubed, we need an x squared. And when we multiply the x squared on both of those terms on the outside, we end up with x cubed plus 5x squared. But remember, we have to subtract. So this is actually a minus, and so is this. Got to switch our signs. These x cubes go away. We're left with 11x squared minus 5x squared, which is 6x squared. Carry down your next term and start over, start fresh. Now we have to go from an x to a 6x squared. So first thing, I always do the number first, so that coefficient out front is a positive 6. We have to multiply this by a 6. We also have to multiply by an x, right? Now work backwards. Draw your distribution arrows. 6x times x is 6x squared. 6x times 5 is a positive 30x. Whoops, where's my x? There it is. And subtract. And when you do that, you are left with 9x, positive 9x. Carry down your last term, plus a 45. And now, we need to start back here again, so let's pick a different color. How about blue? So this blue x, how does it go into a 9x? And that is by multiplying by a positive 9, so plus 9 up at the top. And last time drawing these crazy arrows, when we distribute the 9 onto both of these terms out here, we'll have a 9x and a 45. And remember to subtract them. And remainder of 0 once again. So our final answer is everything that's left on top, which is x squared plus 6x plus 9. So there's your answer to the last example. And we will do more of this in class tomorrow, and we will also be doing some factoring with polynomials.